This is our fourth and final series in little video tutorials on cost estimation, and this is going to be interpreting regression analysis. In our last video, we prepared this scatter graph and regression analysis based on our demonstration problem where our analyst was coming up with a formula for overhead costs, for the manufacturing overhead, based on machine hours. So the overhead amounts are our cost pool, the machine hours are our driver. The machine hours for our analysis was the x-axis, and the overhead amounts is on the y-axis. So let's see what the results of our analysis are, beginning with our scatter graph. Let's first of all look at our linear line. It begins just a little bit above 4,000, about halfway between 4,000, or a quarter way between 4,000 and 6,000. So let's see, that's about to be 2, a quarter, that'd be 500. About 4,500 is where the line intersects the zero machine hours. Well, by definition, right there would be our fixed cost. So the fixed cost would be about 4,500. And now we go out and we look as the number of hours increases, we start coming to our overhead costs. And the first thing we want to do is look for any outliers. That is, any numbers that are well away from the line. We have a couple of here that are of medium distance from the line, but they're really not what we would consider an outlier. An outlier would be a number up here, way down here, someplace well off the line. When you have outliers, you have to consider either eliminating the data or going in and looking at that period a little closer to see if you can find some type of adjustment that has to be made. Remember, these are estimates, so we have some flexibility over the data that we're going to include. All right, so this line looks pretty good. The data's packed around that line pretty good. Now, when we ran this scatter graph, we asked for an equation, and we got this equation: y equals 11.025 x plus 4508. All right, so we know we're dealing with a cost equation, so let's translate that into our cost terms. Y being our overhead cost, so we're saying our total overhead cost equals $11.025 times x. X is our machine hours. So this is our variable portion of the equation, plus 4508. Remember, we said that at 0 hours our costs were about 4,500. Now we know it's 45.8, and that is our fixed cost. So the equation gives us our variable cost per unit and our fixed cost, and we would then solve for our total overhead estimate by inputting the number of estimated machine hours in the period. So that is just based on our scatter graph. This R square tells us just how good a relationship is between our cost pool and our cost driver. So here we can explain about 79% of the cost based on the relationship with variable cost to fixed cost. So this is a pretty good match. All right, so that's just based on our scatter graph. Now we ran our regression analysis. So we're going to look at a couple of statistics here. And there's a lot of data, much of which we could really skip over. So let's take a look at these two numbers. Again, these two numbers, the multiple R and the R squared, which we talked about up here, tells us just how tight the data is packed around this line. And here we have it a number of just about 89%, and that is a very good R factor. So we would say that there is a good relationship between manufacturing overhead cost and machine hours. And again, the R square says that as the cost driver, machine hours managed to explain about 79% of the variations in overhead cost. Okay? We can skip over a lot of this other statistics and come down here. And these are our two numbers that we calculated for our formula. We see here machine hours, and that is giving us our cost driver, and this coefficient of 11.025, well, that's our cost per machine hour. So the coefficient for the machine hour is our per unit cost in our variable cost function. This intercept, its coefficient is our fixed cost. Alright, so the next one we want to look at is our T-stat and our p-value for the machine hours. And again, this is a measurement of just how reliable our variable equation is. Just how good is that 11.025. For our T-stat, the general rule of thumb is that we consider this to be acceptable if the T-stat is greater than 2. And here 6.1, that's very good. For our p-value, if this number is very close to 0, that also says that we have a nice fit around our linear line. So we can be pretty confident using this cost equation to predict total overhead cost. Now, we have a little duplication here. We want to just concentrate on one of these. Our upper 95% and lower 95%. This says that we can have a 95% confidence level that the variable cost per unit falls in the range of about, it looks like about $7 to about $15.05. So again, the distance between the lower and the upper gives us a measure of the comfort. The same with the variable cost. With a 95% confidence, we can say it's between $2,946 and just about $6,070. So again, these data is used to see just how reliable this equation is in predicting cost based on machine hours used. That is the key things you need to know about regression analysis. In the book they talk about multiple regressions, looking at machine hours, looking at overhead, looking at a third factor, a fourth, so on. It's really more of the same. Let's just stay with this, and if you can understand this, you're well on your way to understanding how we use regression analysis in cost accounting.